So, it's reported that xAI is going to hit that 1 gigawatt scale early 26 and full 2 gigawatt by year end. How do you think they'll utilize that in the context of scaling laws? Is a lot of that inference? Is a lot of that training?
It ends up being all of the above. So I think that all of your decisions when you're training a model come back to pre-training. So if you're going to scale RL in a model, you still need to decide on your architecture that enables this. We were talking about like other architectures than using different types of attention. We're also talking about mixture of experts models. This sparse nature of MOE models makes it much more efficient to do generation, which becomes a big part of post-training. And it's like you need to have your architecture ready so that you can actually scale up this compute. I still think most of the compute is going in at pre-training because you can still make a model better. You still want to go and revisit this. You still want the best base model that you can. And in a few years, that'll saturate and the RL compute will just go longer.
Is there people who disagree with you that say basically pre-training is dead? It's all about scaling inference, scaling post-training, scaling context, continual learning, scaling data, synthetic data.
People vibe that way and describe it in that way, but I think it's not the practice that is happening.
It's just the general vibe of people saying this
The
thing's
excitement
dead.
is elsewhere. So the low-hanging
Yes.
fruit in RL is elsewhere. Like, for example, we released our model in November. For every company has deadlines. Our deadline was like November 20th. And our RL run was 5 days, which compared to 2024 is a very long time to just be doing post-training at a model of like 30 billion parameters. It's not a big model. And then in December, we had another release, which was just we let the RL run for go for another 3.5 weeks, and the model got notably better, so we release it. And like that's a big amount of time to just allocate to like something that is going to be your peak for the year. So it's like
So
there's these
reasoning
types
is
of decisions that happen when they're training a model where they just like can't leave it forever. You have to keep pulling in the improvements you have from your researchers. So that's like you redo pre-training, you'll do this post-training for a month, but then you need to give it to your users, you need to do safety testing. So there's kind of just like, I think there's a lot in place that reinforces this cycle of just keep updating the models. There's things to improve. You get a new compute cluster that lets you do something maybe more stably or faster. It's like you hear a lot about Blackwell having rollout issues where at AI2, most of the models we're pre-training are on like 1 to 2,000 GPUs. But when you're pre-training on 10,000 or 100,000 GPUs, you hit very different failures. So GPUs are known to break in weird ways. And doing a 100,000 GPU run is like, you're pretty much guaranteed to always have at least one GPU that is down. And you need to have your training code handle that redundancy, which is just a very different problem. Whereas like what we're doing, like I'm playing with post-training on DJX Spark, or you have your book, it's like, or people learning ML, it's like what they're battling to train these biggest models is just like mass distributed scale. And it's very different, but that's somewhat different than like, are these like that's a systems problem in order to enable the scaling laws, especially at pre-training. You need all of these GPUs at once. When we shift to reinforcement learning, it actually lends itself to heterogeneous compute because you have many copies of the model. And to do a primer for a language model reinforcement learning, what you're doing is you have two sets of GPUs. One is, you can call it the actor, and one you call the learner. The learner is where your actual reinforcement learning updates are going to do. These are traditionally policy gradient algorithms, proximal policy optimization, PPO, and group relative policy optimization, GRPO, are the two popular classes. And on the other side, you're going to have actors, which are generating completions. And these completions are the things that you're going to grade. So reinforcement learning is all about optimizing reward. And in practice, what you can do is that you can have a lot of different actors in different parts of the world doing different types of problems. And then you send it back to this highly networked compute cluster to do this actual learning where you take the gradients, and you need to have a tightly meshed network where you can do different types of parallelism and spread out your model for efficient training. So there's just like a lot of every different type of training and serving has these considerations you need to scale. Like we talked about pre-training, we talked about RL, and then inference time scaling is like, how do you serve a model that's thinking for an hour to 100 million users? I'm like, I don't really know about that, but I know that's a hard problem. And in order to give people this intelligence, there's all this systems problems, and we need more compute, and you need more stable compute to do it.
But you're bullish on all of these kinds of scaling, is what I'm hearing. On the inference, on the reasoning, even on the pre-training.
Yeah, so that's a big can of worms here. But so there are basically the knobs are the training and the inference scaling, where you can get gains. And so in a world where we had, let's say, infinite compute resources, you want to do all of them. So you have training, you have inference scaling, and training is like a hierarchy. It's pre-training, mid-training, post-training. Changing the model size, more training data, training a bigger model. It gives you more knowledge in the model. The model, let's say, it's like a better base model back in the day, or we call it foundation model, and it unlocks. But you don't, let's say, have the model be able to solve your most complex tasks during pre-training or after pre-training. You still have these other unlock phases where you have mid-training, long context, for example, post-training with LRVR that unlocks capabilities that the model has in terms of just knowledge in the pre-training. And I think, sure, if you do more pre-training, you get a better base model that you can unlock later. But like Nathan said, it just becomes too expensive. So we don't have infinite compute. So you have to decide, do I want to spend that compute more on making the model larger? But it's like a trade-off. It's like, in an ideal world, you want to do all of them. And I think in that sense, scaling is still pretty much alive. You would still get a better model, but like we saw with GPT 4.5, it's just not worth it. I mean, it's like, because let's say you can unlock more performance with other techniques at that current moment, especially if you look at inference scaling. That's one of the biggest gains this year with o1, where it took a smaller model further than pre-training a larger model like GPT 4.5. So it's like, I wouldn't say pre-training scaling is dead. It's just like there are other more attractive ways to scale right now at the moment. But at some point, you will still want to make some progress on the pre-training. The thing is also to consider, where do you want to spend your money? If you spend it more on the pre-training, it's like a fixed cost. You train the model, and then it has this capability forever. You can always use it, and so forth. With inference scaling, you don't spend money during training. You spend money later per query. And then it's also like the math. How long is my model going to be on the market? If I replace it in half a year, maybe it's not worth spending $5 million, $10 million, $100 million on the training it longer. Maybe it's just, I will just do more inference scaling and get the performance from there. It maybe cost me 2 million in terms of user queries. It becomes a question of how many users you have and then doing the math. And I think that's also where it's interesting, where ChatGPT is in a position, I think they have a lot of users, where they need to go a bit cheaper, where they have that GPT-5 model that is a bit smaller. Other companies that have, let's say, if your customers have other trade-offs. For example, there was also the Math Olympiad, or some of these math problems where ChatGPT or OpenAI, they had a proprietary model, and I'm pretty sure it's just like a model that has been maybe fine-tuned a little bit more, but most of it was during inference scaling to achieve this peak performance in certain tasks where you don't need that all the time. But yeah, long story short, I do think all of these pre-training, mid-training, post-training, inference scaling, they are all still things you want to do. It's just finding, at the moment in this year, it's finding the right ratio that gives you the best bang for the buck, basically.